Good morning, class. What we're going to discuss today is about Coulomb's law, not Coulomb's law, as Jose brought up yesterday, which I don't believe exists. He says he's going to bring in some research that proves that there is such another law. But I think he's just pulling our legs, so to speak. Anyway, what do we know about charges? What are the different types of charges? Maribel? Yes, we have positive and negative charges. Can you explain to me what happens with the charges and how they attract one another or repel one another? The laws of attraction, right. Positive and negative charges attract. So, unlike charges attract, like charges repel. Okay. You're asking me why, we talk about people and how they say that opposites attract. Well, if you're the same type of person, then you may not bring out certain personality traits that would be in an opposite personality. So if you have somebody who's always happy all the time, right, and somebody who's always sad, then they might balance each other out. Because it's something that makes things more interesting, right? And when you have a balance of things such as charges and personalities very similar, and you're going to balance things out so that it becomes equal and kind of an equilibrium, right? A lot of times you meet someone and you say, I really like him because he makes me laugh, right? Maybe because you don't laugh, so it's opposite. Do we have charges in our bodies? Yes, we do. Every one of us, every object, every animal, every creature, every mass, such as the earth and the moon and the sun, the planets, all right, they all have properties of attraction. The bigger the mass, the more the attraction. Now, we had learned a while back about gravitational force. And basically, Coulomb's law is very similar, almost identical to the law of gravitational pull. Only on a smaller scale, down towards the atom, which we learned about in just the previous class yesterday. So, why don't we feel the presence of Jose? Even he's sitting in the front row, even though he wants to sit in the back. But Jose, why don't I feel you attracting me and vice versa? Why don't I feel your charge? Because I'm more positively charged and you're negatively charged right now. I'm joking. Anyway, it's because we basically are neutral. We don't really have free electrons. Okay, and we'll get into more detail about that. But basically, we're similar in mass. Well, I'm, relatively. I'm not going to tell you my weight, but we're similar in mass. Okay, but you have you can pretty much understand the pull of gravity and our attraction to the Earth, because the Earth is such a large mass in comparison to ourselves. So you can really feel it, but it's so negligible between me and Jose that there's really you can't physically feel it. However, how do our bodies run? Must have learned this in living environment, indoor biology. Some of you, I know some of you are in different classes right now, but okay. So, what does our body run on? Electric charges. And do you know that you could actually power items with your blood? Yeah. We'll get more into a lot of specifics later on, but today, you know, I want you to think about these things and how electromagnetic forces and microwaves and x-rays and all of these things do affect our physical body. And we need to understand these things because we'll know how things work, and we'll be better able to protect ourselves from things such as x-rays, electromagnetic forces, which you also have, which is somewhat negligible in your cell phones, but it's not a terrific idea to have it attached to your head 24/7. So these are the things we have to consider. And as I discussed before, Coulomb's law is very similar to the universal gravitational law. And let me show you what that is. Okay, we have here, if you could see right in this area over here, the electrostatic force, or Fe, which is also measured in newtons. Remember when we went over Newton's laws? Okay, John, yes, thank you. Yes, it's the same thing. However, these charges are measured in what? Well, you didn't learn that yet, so I got to tell you. It's measured in coulombs. Why is that? Because the guy who discovered it was named Coulomb. He was a French scientist. And that's something you're going to research later on, because you need to know the history about this as well. It'll help you later on in life. So if you look at this, again, what does this look similar to? What did we discuss about earlier in class? Yes, that's correct, Maribel. Again, it's very similar to the universal gravitational force, right? Because we have the two charges, and then we have the distance between them squared at the bottom. So this would be similar to the two, since the atoms and or particles are very small in mass, it's negligible. So we're looking at the charge instead of the mass. But this is basically very, very similar. Okay, and this is a constant, like the universal gravitational constant. And this allows us to understand the nature of particles and atoms, all the way down to those tiny, tiny particles. So this will help us not only in the fields of physics, engineering, and technology, but also in the field of medicine. And we will continue with this tomorrow. Remember, the homework is on the board, and make sure that you attempt to do those Regents questions. I know you even have the books with the answers, so I look forward to continuing this lesson tomorrow, and have a good night.